Hello, Math 2318 students. We are going to be proving the invertible matrix theorem pretty much all semester. We'll keep adding more tools that make things easier and more powerful. But just like to say that what I'm doing in these videos, Lemmas 1 through 10, that you might have spotted on the channel. Today I'm going to talk about how all that fits in to prove the invertible matrix theorem, which your book actually doesn't do. Your book uses a concept called pivots and properties of pivots that they never prove. And then they rely on those properties as part of their proofs in the future. Very weak, very hand-wavy. So this effort is to show you how to prove these things without using pivots, okay? So if you look at page 114, section 2.3, that's where the invertible matrix theorem is stated in the book. And it has properties A through J, I believe, that are related. And we are going to look at all the ones that don't involve pivots and actually prove all the implications in between, okay? So now before we get to chapter 3, once we get into chapter 3, the picture is going to be improved. As I was saying, through the whole semester, we're going to keep improving this theorem. But before chapter 3, essentially this is what's going on. This picture I have for you here, okay? So you can see on page 114, there's properties A and B. One is that A is an invertible matrix, and B is that A is a row equivalent to the identity matrix, okay? All right, so those two main properties are linked by a bunch of other properties. For example, that A is invertible can give you property J, that there exists a left inverse. And that can give you these three properties in here, okay? One of which is that the associated transformation T sub A is injective. That's 1-to-1. That's another way of saying 1-to-1. Another one is saying that the columns of A form a linearly independent set. That will become very valuable in the near future. And you can read those, and you're going to see within the lemmas, you're going to see a proof of all these implications I have here. So everything as an implication symbol up here is something that I proved during the lemmas. And I'm going to give you a guide to all the lemmas where they fit in a minute. But I want to give you this overview first. So A is invertible implies this set of properties. It also implies this set of properties. But if you notice, the arrows only go one direction. In here, they go around, but there's nothing that comes back out to say, therefore, A is invertible. And that A is invertible implies there exists a right inverse, which can give you that the associated transformation is surjective, or that the column space of A is equal to all of Rn, right? The arrows go in one direction, so it's kind of like this is a dead end. So this is one little cul-de-sac dead end. This is another little cul-de-sac dead end, okay? There's another way to get into those cul-de-sacs. If you assume that A is row equivalent to the identity matrix, it can be proved, and I do prove it within the lemmas, that implies all these properties are true, and also over here that you can go from A is a row equivalent to the identity to get to this dead end, this cul-de-sac of properties. But there's nothing that comes back out of those towards this, or out of that towards this, okay? So how do we link A and B? Ominous. Well, actually, this statement that A is row equivalent to the identity implies A is invertible is very easy. Okay, don't need much. Just some of these these lemmas Yeah, hardly any of the lemmas even. The properties are, it's pretty easy. But this other direction, that A is invertible implies that A is row equivalent to the identity matrix, that's a bit sketchy. Okay, now your book kind of leans on this whole pivot idea, which is really nebulous. But I have here in Lemma 8 a way of showing this that relies on using some of the other lemmas. That's why there are those other lemmas. Okay, now before I go to what each of the lemma videos are about and how they relate to this picture, I would just like to give you a little overview to the future here, that once we're in chapter 3, where we have determinants. You see this? Yes, okay. So think of this four-sided figure here as representing the 1, 2, 3, 4, okay? And so there you see the little green triangle that talks about exists a left inverse, or that T sub A is injective, or that the columns form a linear independent set. And over here, think of this triangle as, okay, there's a right inverse, or T sub A is surjective, or the columns of A span all of Rn. Okay, so that foregone there is basically these four right here. Now, before we had determinants, we have these implications going from here to there, from here to there, and from this to here to there, here to this, what relates these two. We only had 5, really, that was going this one way. How to get this proof back in this other way without using pivots, without using that sketchy Lemma 8. That's when determinants are going to be very helpful. Okay, so think of this down in the plane, and this is a point out here on this geometric figure. So it's up and out here. You can get from there to there by going up. Here we can prove in statement 6 that there exists an inverse implies that the determinant of A is not equal to 0. And from that statement, the determinant A is not equal to 0, we can prove that A is row equivalent to the identity. Okay, so having determinant not equal to 0 as a property in chapter 3 is going to finish the job completely. Okay, back over here in chapter 2, there's either sort of sketchy Lemma 8. Well, let's talk about that. It's not that sketchy, but it's just kind of, I think, long, drawn out. And at least it's more solid than using pivots. Okay, so now let's talk about your guide to all those lemmas. You have 10 lemmas proved to you in a number of videos. Okay, so I'm assuming you can see all the way down to here. Okay, good, yay. All right, so here's your guide to all those lemmas. If you want to take a picture of this and the next view, then you can have that on your phone and help you decide which of those videos you want to watch later. Okay. So Lemma 1 was that any elementary matrix is invertible. We kind of discussed that within section 2.1 video, 2.2, yeah, 2.2 video. But here it's really proved quite well. If you want to go over that, there it is. Lemma 2 was that if A and B are invertible, their product is. You remember that? That's one of those one-line wonder type proofs. That was very nice. Lemma 3 is just thrown in there to be kind of consistent with the notation. The transpose of the product is the product of the transposes but switched. We discussed all that in the video on section 2.1 and 2.2. Okay, so now here's some new stuff. First of all, in the Lemma 4 video, it proved that if A is invertible, its transpose is invertible. Take a look at that. That's really nice. Lemma 5, that if A is invertible and B is row equivalent to A, then therefore B is invertible. So Lemmas 4 and 5 are brand new, not in the book. Very nice. Come and take a look at Lemma 6 now. So Lemma 6 was made to show basically the working lemma 6 and 7, basically fill in all those implications that are in the green triangle, that T sub A is injective. Okay, so you want to learn about that green triangle over there, and it's why all those implications are true. Go to lemmas 6 and 7. I think that's in one video. Possibly not. All right, so let's see, lemma 8. What else we got over here? Good, okay, now we've got more. All right, so lemma 8, here's the sketchy lemma 8, sketchy, quote unquote, that if A is invertible, then it implies that A is row equivalent to the identity matrix. Now, to be able to do that without using pivots, right, that's why I needed lemmas 4, 5, and 7. So I use lemmas 4, 5, and 7 in the proof of lemma 8. Okay? So again, where does lemma 8? Lemma 8 goes from A is invertible to A is row equivalent to the identity without using determinants. Lemma 9 right here, that A is row equivalent to the identity implies A is invertible. That was that, that's this direction. That's easy. You only need lemmas 1 and 2. Lemma 10 gives you all the implications within the red triangle, that T sub A is surjective, that the columns of A span all of our n. So everything within that part is taken care of there. Okay, so that should give you all the behind story of this overview. Okay, we haven't got to determinants yet. When we have, we'll come back to that one. But using all those videos on those lemmas, you can see why all these things are true.